Welcome back to the channel. After completing 90 rounds of successful outcomes of the Martingale strategy, I am back again with a banger video, and since I am very close to 100 rounds today, we're diving into the geometric probability distribution, a powerful concept in probability and statistics that answers the question, how many tries will it take until we succeed? And a very important distribution function that I am going to use for modeling later in the coming videos. Let's break it down. A geometric probability distribution is a discrete probability distribution that models the number of independent Bernoulli trials with two possible outcomes, success or failure, needed until the first success occurs. The geometric experiment possesses the following properties. 1. The experiment consists of a fixed number n of identical trials. 2. Each trial results in one of two outcomes, success or failure. 3. The probability of success on a single trial is equal to P and remains the same from trial to trial. The probability of failure is equal to Q equals 1 minus P4. The trials are independent. 5. The random variable of interest is Y, the number of successes observed during the N trials.
So now that you know the property of the geometric experiment, it is the time now for me to explain to you the geometric probability distribution and justify it mathematically. So, if you let the random variable y be the total number of trials needed for the first success to be observed, then y is said to have a geometric distribution with parameter p. That is, y follow gp, that is the geometric probability distribution, and the probability mass function is given by py is equal to p q to the power y minus 1. For y is equal to 1, 2, 3, 4, 5, etc. Otherwise, py is equal to 0, as you can see here. I hope everything is clear. Let me just repeat again. Py, that's the probability of y, is equal to pq to the power y minus 1. For y is equal to 1, 2, 3, ... Otherwise, probability of y is equal to 0. Now, if we come back to our experiment, that is the Martingale strategy experiment in football prediction for the total goals even of 2 matches. Yes, these are the data of the football matches I have been correcting and recording. Here, if you look at the results now from round 81 to 90, you can see we started very well with T9, which means the success here was observed after 8 failure. And as always, we bet 1,280. In this case, the profit we got here was 1,707.4. In round 82, T10, meaning no success was observed here, and we stop and start over. So as a consequences of that, we always lose huge amount of money. In this case, we lost 2,555. It has become a norm now, and I hope you understand. So I'm not going to go through everything. And as you can see, the sequence continue from round 83, T1, T8, T1, T1, T4, T2, and again in round 89, T1. But unfortunately, in round 90, T10 happened, and here there was no success observed in those 9 trials we take, and we accept a huge loss of 2,555.0 again. That was it. Now, if I take the summation of profit or loss from round 81 to round 90, you can see here clearly that we made a loss of 2,436 points. And just imagine last time we made that magnificent profit, but this time around we made this loss. So now if I take the summation of profit or loss from round 1 to round 90, since the first time I started this experiment to round 90, where I am currently at, you can see I am standing at a loss of 608.6. 608.6 is the loss that I'm currently making. So that's it. Now I must just justify one thing. Yes, as I try to connect the geometric probability distribution to the Martingale experiment I'm currently doing. So in our case we have Tn. You can equate that to y in the probability mass function of the geometric distribution, and probability of Tn is equal to probability of y, and probability of T1 is equal to probability of 1 in the case of the geometric probability distribution here. So I think everything is clear, and you can just go and punch in the number and get the result, but I won't do that until I reach 100 rounds, which is very close. So I hope you enjoy the video.
To conclude this video, the Martingale double after loss looks like a sure win plan, but it hides huge tail risk. Whether it is attractive depends completely on the win probability, the payout structure, and real-world constraints, finite bankroll, and table limits.